what we need to do is to define a class like this, which allow you to enter the denominator coefficients, numerator coefficients, denominator orders, and numerator orders, which are given in vectors. So we can define a class or object in this way. And to define an object in Matlab, what we need to do is to create a folder first. The folder must start with @FOTF. And in this folder, we must at least establish two files. One is the definition of this class, which is given FOTF.m. You must write this name, you cannot use other names. The other one is display.m, which is used to display a fraction order transfer function. So those are the essential files you must create in that folder. After you have created a folder like this and created two essential files, then you can write other files. Usually you can use overload functions, which means that you can write functions like this, but for the functions should be placed under this folder, and the function names could be the same as the one for other toolboxes, such as the control system toolbox. You can use the same name, and I will explain that one later to you. So for the folder, I said there are two essential functions, and this is one of them, which defines FOTF object. And the other one is how to display the object. These tools are essential. I'm not going to give details on these functions. I think you can download the PPT files and code, zipped code files. I've listed the files in the course web page, so you can download them. And now there is a question: how can we represent such a system under Matlab? With the use of FOTF, with the use of FOTF object, we can describe the fractional order transfer function easily by describing the numerator coefficients in B, the orders of numerators in NB, the coefficient of denominators in A, and the orders in NA. Then we can call a FOTF function to create such an object inside Matlab environment. So the command we use should be like this, and then you will get a transfer function block inside Matlab, which could be the same as the one I specified in the example. So you see there are two functions we need to use. One is this function, which is used to create the object, and the other one, this part, is obtained by the display.m function. So those two functions are essential. So in this way, we can create a fractional order transfer function. So what about the interconnections of fractional order transfer functions? In control, what we usually use the connections are the series connection, and in mathematics we will express the overall system from U to Y by G2 times G1. And for parallel connection, in mathematics we will represent the overall system by G2 plus G1. And for single input, single output system, these two blocks can be interchangeable. So these are the typical series and parallel connections. And also in the control system toolbox of Matlab, you can still use times and plus signs to combine blocks together. And apart from that, we can define the positive feedback and the negative feedback using the feedback function of Matlab. And if you are using a negative feedback, what you need to do is to define function feedback, which allow you to give G1 and G2 and leave the rest of it. Then you can get the overall system from U to Y. If you are using a positive feedback, you must have a 1 here as a third argument. So this is the definition used in the control systems toolbox. And in the fractional order transfer function toolbox, what I want to do is to create similar commands, multiplication and plus and feedback functions.
So in that example, the comma should be before the bracket, or is it
just if it is a negative feedback, just delete this part.
No, it's positive. It's bracket, comma.
No, you do not have to use that. Right?
No,
that's kind of.
No, I mean, is that
in positive, you have to delete that one. You do not have to use the bracket. I think that's the kind of notation used in early versions of computer languages. So just forget about it. You can remove the bracket. The bracket is not used. Actually, I want to indicate this one is optional.
Okay, but 1 is going to be represent positive.
Positive. If it is a positive feedback, then we have to use 1, but we do not use the bracket.
So you're just passing an argument.
There's argument. Yeah, extra argument actually. And if it is a negative feedback, we can omit this part totally. Maybe I should not write a question like this. It's confusing. Actually, the bracket is not used.
Yeah.
Okay. So this is the target I want to create. If it is a series connection or parallel connection, I want to redefine the multiplication and plus functions. And if it is in feedback connections, I want to redefine feedback.m function in the FOTF block, TF folder. So for the overload function, to redefine the multiplication sign, we need to create a Matlab function, which is the name should be n times s, which is a standard name. If I use this name, I can redefine the function multiplication function. And the function should be, the detail of the function should be like this. And this is the mathematical detail of the algorithms. And there is common function in that folder. And you must put this function under the FOTF folder. You cannot put it in other folders, otherwise there might be problems. So this function is defined only for fractional order systems. And also we can define the plus sign by rewriting a function plus in that folder. And we can define the feedback function by writing a feedback.m file also in that folder. So we can use the functions directly. Now I will demonstrate this part.